HTML injection. Let's first gain an understanding about HTML injection. Hypertext markup language injection is a technique used to take advantage of non-validated input to modify a web page presented by a web application to its users. Now, attackers take advantage of the fact that the content of the web page is often referred to previous interactions with users. So when applications fail to validate user data, an attacker can send HTML formatted text to modify site content that gets presented to other users. Now, a specially crafted query can include attacker-controlled HTML elements in the web page, which change how the application content gets exposed to the web. HTML injection could be defined under code injection, which applies to client-side injection attacks or server-side injection attacks, depending on the processing. Now, this is because we are injecting code which changes the web page to that of the browser's interpreter is strict into representing code in the context of HTML. This being a client-side render does not affect the server-side components, although there are possible attack instances of the client to server-side injection which could be leveraged to bring server-side data destruction. One such example could be server-side JavaScript injection. Now, any attack on the JavaScript browser interpreter must be client-side, but there are scenarios where an attacker could leverage to server-side compromise of data followed by client-side attacks. Hence, it does not matter how injection is classified. However, what does matter is which assets are at risk. Is the asset a client-side object or server-side data? Leveraging client-side attacks to bring server-side havoc is completely onto the attacker and the scenario in which the attacker fails. Moving on to the types of HTML injection, there are two main types of HTML injection, which are stored and reflected HTML injection. Let's understand each one in detail. Let's begin with stored HTML injection. The main difference between those two injection types is that a stored injection attack occurs when malicious HTML code is saved in the web server and executed whenever the user calls an appropriate functionality. However, malicious HTML code is not permanently stored on the web server in the reflected injection attack case. Reflected injection occurs when the website immediately responds to the malicious input. Moving on to the second type, which is the reflected HTML injection. Now, HTML injection occurs when a user can control an input point and inject arbitrary HTML code into a vulnerable web page. This vulnerability can have many consequences like disclosure of a user's session cookies that could be used to impersonate the victim, or more generally, it can allow the attacker to modify the page content seen by the victims. Reflected HTML injection can be further divided into three types such as reflected get, reflected post, and reflected URL. Reflected injection attacks can be performed differently according to the HTTP methods get and post. With the post method, data is sent, and with the get method, data is being requested. Let's understand this with a practical illustration. Practical. This demonstrates an HTML injection, reflected attack in the get function. For this demo, we'll be using BWAP, a buggy web application that we can use to test various vulnerabilities in the web. Please choose HTML injection reflected. Get from the drop-down menu and click hack. Go to test. Let's try to point the first name as hello and the last name as hello and click on go. You can observe we got a message welcome hello hello. As you can see, it's getting reflected. Let's try our first attempt to attack. We can add some HTML tag for the input field. Hence simple in the first name field, the input given is a simple HTML tag, that is a header tag h1 hello h1. The same follows with another field. As this application is vulnerable to HTML injection, we can inject HTML h1 tag which will reflect our name. Let's now intercept the request with the burp suite. As you can see, the first name and the last name are getting URL encoded on the client side, but still our HTML tag is getting implemented, so there is no protection against the HTML injection. Let's upgrade the level to medium and let's try to print the first name as hello and the last name as hello and click on go. You can observe I got the welcome hello hello. Now let's try using the same payload as low level with an HTML tag. As you can see now the payload is getting the plain text payload. Let's intercept the request with the verb suite with the first name as hello and the last name as hello. As seen, the value of the first name and the last name is getting reflected in the get parameter test. Try with payload and intercept with burp. The script tags are getting URL encoded on the client side, so let's add the script to the burp request. This method is also not working, which means it is getting encoded on the server side. To bypass that, let's try to put URL encoded script in the burp request. For that, we are using a decoder from verb extensions. So we URL encode the HTML script tag twice. And we get the encoded string as a result. So let's replace the test string with the encoded string and forward the request. As you can see, attack got successful on medium level. HTML injection reflected post attack. Please choose HTML injection reflected post from the drop-down menu and click attack. Reflected post HTML injection is more difficult. It occurs when a malicious HTML code is sent instead of the correct post method parameters. So to test, let's try to print the first name as hello and the last name as hello and click on go. You can observe I got the message welcome hello hello. As you can see, it's getting reflected. Let us intercept the request with the burp suite. As you can see, the first and last names are sent through the body of the request with the post method. Let's modify the fact name by putting the HTML h1 tag with the hello string. As evident, HTML injection is being reflected, indicating that our attacker successfully identified vulnerabilities at the low security level. Let's upgrade the level to medium and let's try to print the first name as hello and the last name as hello and click on go. You can observe I got the message welcome hello hello. Let's try using the same payload as low level with an HTML tag. As you can see now, the payload is getting the plain text payload. To bypass that, let's try to put URL encoded script in the burp request. For that, we are using decoder from burp extension, so we URL encode the HTML script tag twice and we get the encoded string as a result. Now let's replace the hello string with the encoded string and forward the request. As you can see, attack got successful on medium. So now let's upgrade the level to high and try the previous payload. As you can see, nothing works. In the high, the HTML injection is fully mitigated. HTML injection reflected URL attack. Please choose HTML injection reflected URL from the drop-down menu and click hack. Reflected URL happens when HTML code is being sent through the website URL displayed in the website and at the same time injected into the website's HTML document. This challenge, you may notice that there doesn't appear to be any input for it. It seems to echo the URL. It doesn't have much real-world application, but I'm sure something out there uses this. But how we can possibly inject into this thing that doesn't have any input? This is where the real hackers are separated from the script kiddies. As it turns, it comes down to the pound sign, or as most young people call it, the hashtag. So why the hashtag? An anchor can simplify and specify an HTML element with the same ID as the text after the character. So if we can add these anchors on the end of the URL with some HTML, it may pass it on the server and display it on the page. So let's try adding some HTML at the end. So if we can add these anchors on the end of the URL with some HTML, it may pass it on the server and display it on the page. Let's try adding some HTML at the end. As you can see, reflecting with hello with the h1 tag means that our attack succeeded. Prevention and mitigation. The most common way to detect HTML injection is by looking for HTML elements in an incoming HTTP stream containing the user input. An unsophisticated validation of user input removes any HTML syntax substrings like tags and links from any user supplied text. However, there are many instances when the application expects HTML input from the user. For example, this happens when the user submits visually formatted text or text containing links to legitimate sites with related content. To avoid false positives, the security mechanism that detects possible injections and protects the application should learn in what application context user input is allowed to contain HTML. Also, it should be able to stop HTML input if it knows that such text is posted as on a web page generated by vulnerable application components. There is no doubt that the attack which occurred was mainly due to the developer's negligence and lack of knowledge. This type of injection attack occurred due to the on-validation of the input and output. It is therefore essential to have appropriate data validation in place to prevent such attacks. Every input should be checked to see if it contains any script or HTML code. One should check if the code has any special script or HTML brackets. For example, script tags or HTML tags. As there are many functions for checking if the code contains any special brackets. The selection of the checking function depends on the programming language that you are using.